Good morning. Sorry that we're having to do this here. This was not my plan here on this Monday morning, a little bit early for me. And I wanted to be there with you guys, but I strained my back, was exercising, and a little bit too much. So I need to give my back some time to rest. So let's make the best of it. Thank you for listening to this video. Let's just pretend as if I'm sitting right there beside you and kind of walking you through this personal preparation for this USA 2 coming up, right? We got that on Wednesday morning for you guys. Unless you're in my fifth period class, right, then we have it on Tuesday morning tomorrow. Okay, so, and it is, I understand you having to feed yourself. It's not easy to do that, listening to this video, but let's make the best out of it if we could. Let me remind you about the lunch detention. So, of course, I will not be there today, but if you can come Tuesday, Wednesday, or even Friday, so I'll give you a little bit more time, gracious on that, to get your lunch detention done if you have received that. But let's try to get it by Tuesday or Wednesday. Okay, so I'll see you on Tuesday or Wednesday for lunch detention if you did receive that this form here. And then also late homework. So that'll be due tonight for my second and fourth period classes. That'll be due on Tuesday night. So tomorrow night is all late homeworks. You can still get up to 48%. No, not 48, 68, my fault. 68%. And then if you don't get it in by this, the night before the USA, let's say it that way, then you'll only be able to get up to 40%. So please make sure to get all these late homeworks in by the night before the USA. Primarily, not just for the grade, but primarily to get ready for that USA 2 that we have coming up here soon. And what else do I need to remind you guys of? That's it. Okay, so let's jump into it. Let me, if I could, go back and remind you of a few terms that I think will be helpful for us. We've mentioned these before, parallel lines. And remember the definition for that? There's two parts of it. They do not intersect, and also they are coplanar on the same plane. I will also mention that they have the same slopes there, and that this is the symbol that we use for parallel lines. And then perpendicular lines, they do intersect. They do intersect, and they create a 90-degree angle. So if you would say these words in your mind, parallel lines and perpendicular lines. Remember, we've already talked about vertical lines going straight up and down, diagonal lines going at a slant, and then horizontal lines. So keep those words in your mind. And of course, we've also talked about a plane, a two-dimensional surface that goes forever in all directions. And then just a few other quick reminders to get these things in our mind. So remember, our fancy word for beside is adjacent. Complementary, when angles are like this, they're beside each other, they're adjacent. And the sum of those two angles is 90 degrees. Linear pair, if they're adjacent and create a line, then they're linear pair. And all linear pair angles are supplementary. The sum of those two angles here is 180 degrees. And then if angles are across from each other, they're called opposite. And two opposite angles created by two lines that intersect, those are called vertical angles. And all vertical angles are always congruent. And then remember these scenarios also. So here we have a right angle. So not only are these two angles adjacent to each other, they're also complementary. The sum of these two angles is 90 degrees. So of course, remember, if you had 2x and 3x here, let's say they said that those are the measures of those angles, then we add them together and then set that equal to 90 degrees. And if two angles are beside each other, they're adjacent to each other and create a line, like we said, they are a linear pair. And so those are supplementary. So therefore, if this was, let's say 3x minus 5, this one was 5x plus 6, then we would take the sum of those two, the measure of those two angles, and then set that equal to 180 degrees. So remember how to create that equation based on that geometric situation there. Okay, can you open up your binder and let's have you guys pull out your 1.4b. So 1.4b, let's go back and remind ourselves of this on this USA that we have coming up. Be it because it's a USA, it's comprehensive. So yes, it does cover all of this information here, but also some information from our USA 1. So in your 1.4b, if you don't have the sheet of paper, then it's on the shelf there. 1.4b. Remember, we have 4. Can I do this here? Yeah, there it goes. So it has 4 different constructions that we need to be familiar with. Copying a segment or bisecting a segment, and then copying an angle or bisecting an angle. Let's kind of walk through these one at a time and remind ourselves of these constructions. No, didn't want to do that. Is that going to work? There we go. And page width. Perfecto. Okay, so we want to copy a segment. Of course, you remember this is a compass. And remember, a compass starts with a C, and we use that to capture distance. So they give us this segment to start with. We want to capture the length or capture the distance of this. It would be the length of the segment or the distance between these 2 points. So that's what we're doing here. And remember, this is an arc, A-R-C, a part of a circle. And then we take that distance that we've captured and then imitate that by drawing another arc down here. And so now we have 2 segments that are same shape, same size, and those are congruent. So we've copied a segment. And then we can also bisect a segment. When you see bisect, let's go ahead and write this in on your paper there. When you see bisect, it means to cut in half. Cut in half. So bi, of course, means 2, and section means, or sect means to section it. So we're sectioning this segment into 2 congruent pieces. So we anchor our compass on one endpoint and draw an arc, and then keep that same distance on our compass and anchor the compass on the other endpoint and draw an arc that intersects with the previous arc that we drew. And remember, oftentimes they'll give us this slide and they'll say, hey, what's happening here? And our job is to realize that we are bisecting this segment. So look for these arcs and where these arcs intersect. And almost always you're going to have a line that goes through that point of intersection of the arcs. So where does this line going to be going? And it's going through here, and hey, here's also another intersection. So it's going to be going through those 2 points of intersection. So the next step is going to be this line here. And what is this line doing? So let me do it this way. What is this pink line doing to this black segment? It is bisecting. So this right here is the midpoint. And then therefore these 2 segments are congruent with each other. So not only is this a bisector, a bisector. It's also intersecting at 90 degrees. And what do we call a line that intersects and creates a 90-degree angle? A perpendicular bisector. So remember that term over here, perpendicular bisector. So remember, they can refer to this construction sometimes as find the midpoint, other times as draw a bisector, or another time as draw a perpendicular bisector. So all those are different ways of referring to this same construction. Now on the back side of your sheet of paper, we're starting with an angle here, and we want to copy that angle. So we place our compass on the vertex of that angle, and then draw a reference arc here. This is a reference arc. And then keep that same distance, and then draw a reference arc on this segment, preparing to create an angle over here. And then we use our compass to capture this distance. So we're capturing the distance between these 2 points of intersection, and then anchoring our compass down here, and then drawing the arc there. So these two distances here, that distance and this distance, are the same. And therefore, when we have like this slide here, you're thinking, okay, what's the next step? So you're looking for this intersection of the two arcs, and you know you're going to have a line going through that intersection, but where does that line go? And it goes down and over to this point here, so that's creating a angle that is congruent. So we could do little arcs here and put tick marks on there. So these two angles now are congruent to each other. We've just copied that angle. All right, that's it. No, it's a bisector. That's right, I forgot. Okay, so we also want to start with a angle here that they give us. This the initial figure that they give to us is an angle, and they're asking us to bisect it. They're asking us to cut it in half. So here's the final result, is this segment that's starting at the vertex and going through that intersection of the arcs. So remember how we do this? We anchor our compass on the vertex and draw a reference arc here. And then we anchor our compass up on this top intersection and draw this reference arc. And then keep that same distance and anchor our compass on this lower intersection, and then draw, do different colors here, hopefully that'll make it a little more sense. Anchor it here, and then draw an arc up on top here. So now we're again looking for where do these arcs intersect, and so through this point. So where is my line going to be going through? And you know, it goes from through that intersection and to this vertex. So now this line that we just drew here is bisecting this larger angle, and we've created two angles that are congruent to each other. Okay, so hold that in mind. Hold that in mind. We're going to come back to these constructions, but now let's go over to your this sheet of paper, the summary of transformations. Let me do a review of another concept that will be on the USA 2. So please pull out this sheet of paper. If you don't have this, then pick it up on the shelves there in the classroom. So let's remind ourselves of these 4 different transformations. Back it out a little bit more. There it is. So remember that a slide, our fancy word for slide, is translation. So in this case, always, say it that way, the pre-image is going to be just the letter, and that then transforms over to the image, which is A prime in this case. So A goes to A prime, C goes to C prime, and so forth. But in this case, with a translation, we're sliding, for example, this point C over here to the right and then down. So sliding is translation. Flip is reflection. We're going to flip it over this line of reflection. So for reflection, they always have to give us a line of reflection. So what am I reflecting this figure over? Rotation is to twist the thing, and they always need to give us a center of rotation, which for our purpose will always be the origin. And then to enlarge or reduce, we call that, as you know, dilation. So in this case, it's getting smaller, going from A down here to A prime. All right, so let's run through some problems. And again, I wish I was there with you. I could have you show me your answer on the whiteboard. But if you would, pause the video a little bit here and think about this and figure out which one of these constructions are being illustrated here. So again, remember we want to look at the intersection of these arcs here. So it's this intersection here that we're looking at, and we know we're going to be drawing a line through that intersection, but where does that line go to? And hopefully you'll remember, it goes from here through the intersection and to this this vertex. And here's another way of thinking about this. Look at what they give to us. Are they giving us an angle that we're starting with, or are they giving us a segment? And of course you can see they're giving us an angle. Okay, so are we copying that angle, or are we bisecting that angle? So if we're going through this intersection of the arcs, you know it's coming through here. Let me do a different color. It's coming through here, and it's bisecting this larger angle into two congruent pieces. So we are bisecting that angle. Bisecting that angle. And so what are we doing here? So what are they starting with? Remember that question first? What are they starting with? And it's this segment here they're starting with. So are we copying the segment, or are we bisecting it? So now we're looking at these two points of intersection of these arcs, and I'll be drawing a line. We will be drawing a line through those 2 points of intersection. So what is this blue line doing to this black segment? And it's bisecting that segment. There it is. It's cutting that segment into two congruent pieces. And remember, it's also another way of saying it is it's creating a perpendicular bisector, or we could also say that this is the midpoint. This is the point that's at, oops, on my point. It's a point that's in the middle of that segment. As we said, these two smaller segments are congruent with each other. All right. Little music here. So then, what are we doing here? What is the construction? So form an answer in your mind. No, I said construction, but I said that wrong. What is the transformation that is happening here? So do pause the video, think about that. Okay, so you might be thinking, hey, this looks to me like a line of reflection, and I agree with you. Kind of seems like we're doing a line of reflection. And so what would be the orientation of that line? And hopefully you remember it's a diagonal. So that line that looks like it's a line of reflection is a diagonal. So if we were to reflect this pre-image over this line of reflection, where would we go? So let's take just one point at a time. So let's take this point B here. And remember that our line of sight will always be perpendicular. So here's that term again. It will always be perpendicular to the line of reflection. So if this is this guy here, this black line is our line of reflection, and then our line of sight has to be perpendicular to that. And remember the distance to the line of reflection, whatever it is, let's say that it's 1, 2, 3, 4 steps to get to the line of reflection. after going 4 steps to the line of reflection, we need to go 4 steps beyond that line of reflection. And so it looks like to me, like this point B it does reflect over to this point here. So is that what's happening? Are we reflecting this figure over this diagonal line of reflection? And the answer is no, as you know, hopefully, because you're like, hey, wait a second. B cannot reflect over to D prime. B has to go to B prime. And if I was to reflect B over this line of reflection, it's going to end up over here. So, and also D would end up being around here somewhere, and A would come way down here somewhere. C would be over here to C prime. Okay, so this is not a reflection, and as you probably figured out now, it's a translation. So take one point here. Let's take point D. Take point D, and notice we would slide over to the right thus far, and go like this, and then we would slide down. So we could do the same thing with a point, let's say it's point C. We'd slide over to the right and then slide down. I could do these in different colors if that would be helpful. C, and then what other colors do I have? How do I do this again? Do I hit this button? No, oh, there it is. Yeah. And then here could go A, be like that. And then what other colors do I have? Why is this not working? Oh, no, it's right. Hit down here. I forget. Sorry, my fault. And then also B. I could go B over to B prime. Okay, so each of these points go to their from the pre-image to their corresponding image. And that's translation. And remember that with a translation, it does preserve. It does preserve distance, meaning that the distance between these two points remains the same in these corresponding points over here, and so forth. Okay, so preserves means to keep or to maintain. Okay, with this one, what kind of transformation could map this pre-image onto the image? You figure it out in your own mind. There we go. Okay. Okay, so what's happening here? So here, looks kind of like a slide, doesn't it? Looks like I'm just sliding. Don't I just do that? Slide this point over there, and then slide this point here over there. Yeah, that's making sense, right? Except, wait a second, B cannot go over to C prime. So I need B to go over to B prime, and I need C to go over to C prime, and so forth. So how am I going to be able to do that? And yes, it's a line of reflection. So I'm reflecting over, and what's the orientation of this line? What would we call that? And vertical. So what would that look like? To reflect this point B over this line of reflection, this vertical line of reflection, I go, let's say 1, 2, 3 steps to the line of reflection, and go 3 steps beyond that line of reflection. And then with point C, let's go 1, 2, and 1, 2. So C is going to go over to C prime. Okay, so yeah, this is a reflection, and we are reflecting over this vertical line of reflection. And remember that for reflection, it does also preserve distance. In fact, what is the only transformation that does not preserve distance? And it's dilation. Dilation is the only one that does not preserve distance. Let's keep on going here. Some music. So what kind of a transformation? And you probably figured out now that it's a rotation. So here's your point of rotation. And so what you do is do one point at a time. So going from point C and then down here to C prime, first of all, what direction is a positive? What direction is a positive rotation? And you should have in your mind going this direction. So what direction is that? And it's a counterclockwise rotation. Positive rotation is counterclockwise. Let's go back and look at our summary here. Transformation. And remember down here, I wrote that for you. So a positive rotation is a counterclockwise rotation. There we go. And so to go from C and rotating around this this point here and go over to C prime, this is, let's do it this way. If I was to go from here to there, that's 90 degrees. And to go from C over to C prime, that's 180 degrees. I'll do it this way. So this should be 180 degrees. And then if I was to keep on going all the way around, just quick reminder that that would be 270 degrees and all the way around. So this is 270. And of course, all the way around would be 360. So in this case, though, it's a rotation of 180 degrees. I said clockwise because you could also go clockwise. If you went to 180 degrees this way, that would end up in the same place. So as you know, this is a dilation. So are we getting smaller or bigger though? Smaller or bigger? And you know, going from C down here to C prime, that's going to be a reduction. So we're getting smaller. So remember your scale factor. We're not really talking too much about the scale factor, but the scale factor is going to be less than 1. Because remember, the scale factor is new over old. New over old. And the new one is smaller than the old one. So this is the new, the prime. And so therefore it's going to be less than 1. So dilation. All right. Go ahead and pull out your USA 2 Review 1. USA 2 Review 1. So it looks, I'll tell you what, I'd like for you, ideally, because I'm concerned that you're going to just go through your Review 1 and just, well, actually, for this question, yeah, question number 2, it's okay for you to look at what you've written, and then you can compare it with these multiple choice questions that we have on the PowerPoint slide that I'm going to show you. But let's do that first. How about you answer this question on your own? That's the way to do it. So you got your USA 2 Review 1, and go ahead and read this question and write down what you think is the answer for that. Let's do that first. Okay, so the question is, write the following statement as a conditional statement. So this is a conditional statement. Make it bigger for us. It is a conditional statement, and we want to put it into the if-then format. So I want if something, the measure of the largest interior angle of a right triangle is, and then this is going to be our then. So if, and notice that all of this part here is a modifier of the word measure. So our noun or our subject is the measure, and all this stuff is modifying. Then here's our verb. So you could say just the measure is 90. So it's going to work out so that the if part is going to be the largest interior right angle, and then the measure is 90 degrees. So let me show you some options. And so look at this, read through each one of these, and figure out your answer. Go ahead and pause the video if you would. Okay, so please do pause the video. And so why is this one, let's see, yeah. Okay, So why is this one wrong? It says if the figure has a 90-degree angle, there it goes, 90-degree angle, then it's a right triangle, or it's a right triangle. So that has a bunch of the words, doesn't it? That has a lot of the words that they started their original statement has. But so why is this one not correct? It's because it does not include the largest interior. We're not including that information. Okay. So sometimes they could leave out the word measure and then just say 90-degree angle because it's kind of inferred there. So I'm not saying that you have to have all of the words from the original statement and all in the same order. I'm not saying that. But you do have to include all the concepts, all the major concepts. So what's wrong with this one? This has now, it does include right there, but again, it does not include the largest interior. And this third one here, if the angle is there it is, largest interior angle, nice. And then it measures 90, right, it's got a bunch of stuff here, but it doesn't have right. So it forgot the word, or the modifier, the adjective, right triangle. So therefore, this C is also not correct. And this now has all that information. It has the largest interior. It also has right. And really, more importantly, it has the if and the then. And it's in the correct order. It makes sense. Remember, if they switch it, that would be the converse of it. If they were to negate it, if they were to say not a right triangle and is not 90 degrees, then that would be the inverse of the original. And if they were to switch and negate both, then that would be the contrapositive. Okay. Sorry to interrupt your musical interlude, but hopefully you're thinking about. So how do you say this? How do you say this term here? And remember, it's the measure of. So the measure of angle 7. So we want to figure out the measure of this angle over here. So how do we find that? Well, what angle? No, I guess not. So there's different ways of attacking this. Let me do it this way. Let's go down here. And remember how important it is, how useful it is to look for straight lines. Look for straight lines. So here we do have a straight line that is related to angle 7. And so let me use this example down here though. So here's a straight line. And what's it called when there's two angles that are beside each other? Okay, so those two angles are adjacent to each other. And yeah, it does create a straight line. So that's a linear pair that they're creating. And those two angles are supplementary. So let's remind ourselves about that concept. Remember how I had you? We started over here. So here's two angles that are adjacent to each other. They create a line, so a linear pair, and therefore they're supplementary. Remember, our definition for supplementary is the sum of the two angles is equal to 180 degrees. So now back over here. So that's true, that these two angles are supplementary. And the same concept is also true here. So here we have a line, and you would not say that these angles, these three angles, are supplementary, but we do know that the sum of these three angles is 180 degrees. So let's do this. Let's add 50 plus 52, so we get 102. So what do we do with that 102? We subtract it from 180. All right, so another way of thinking about that is that this part here is well, the whole do this way. The whole thing is 180 degrees, and then you take away this 50 degrees, and then you take away this other 52 degrees, and you're left with just the measure of angle 7. And so, of course, that's 78 degrees there. All right. And while I'm here, what is the relationship between angles 7 and 5? What's the relationship between angles 7 and 5? So we have two lines that intersect, and these angles are opposite of each other and created by two lines that intersect, and therefore these angles are vertical. And what is true about vertical angles? Quick reminder that vertical angles are always congruent. Vertical angles are always congruent. So therefore, back over here, and can I back out of this? I think I can. Remind myself how to do this. Why is my... No, hold on. Okay, so never mind. I think my little hotkey here is not working, but I can do it that way. Okay. So these two angles are vertical and always congruent. So we said this angle, angle 7 was 78. So angle 5 would also be 78. Okay. And then even angle 4, you can pick that up. That's vertical with angle, this 52 degree angle. And then they're not asking for this angle, so don't worry about that. Okay, that's good enough for now. So 5th period, you guys can... Eardrums. All right, so please do think about these and read through these words. And yes, this is the same as your USA 2 Review 1, but don't just go and figure out what your answer was and slop it down there. Actually, rethink. Go back through and rethink these statements here. So which of these following statements are not valid? Not valid. So any point that lies on the bisector of a segment is equidistant from the endpoints of the segment. So what we're really doing, can I go back? Let me do that, is this. So any point that's equidistant on a segment, a bisector of the segment, or no, wait, hold on, wait. Oh, yeah, that's right. I'm just remembering back to this other problem that, yeah, tell you what, let's not cover that one first. Let's jump down here. Let's cover this one first. Okay, so which of the following statements is not valid? That's a key word. I'll get to this later, but for right now, let's go down to this one. If two lines are coplanar and they do not intersect, then they're parallel. Okay, so parallel. What is parallel? Remember we talked about this before? That they don't intersect. Yes, that's true, but also they have to be coplanar. So there's two parts of the definition for parallel. So here we go. Two parts, the definition of parallel. Let me also just draw your attention to this. That notice here we have single arrowheads. That tells us that these two lines are parallel. And here we have double arrowheads. Tell us that this pair of lines are also parallel. We would not want to have, for example, all double, because this would say that all four of these lines are parallel to each other. But the main thing we want to pick up is that there's two parts. I should have a number 1 and number 2 here. Two parts of this definition, that they don't intersect and they're coplanar. Now coming back over here, hey, we have those two parts. And so is this statement true? And the answer is yes. This is a true statement. This is a true statement that we have. So is that the answer? And no, it's not the answer. And why not? Well, because they're asking for which of the following statements is not valid. So that's kind of tricky. So first figure out whether the statement is true or false, and then figure out whether or not it's the answer to the question. Two pairs of vertical angles are formed when two lines intersect. So here's your two lines intersect, and yes, let's call this angle 1 and this angle 2. So, or let's do it this way, because really what they're saying is two pairs. So here's one pair of vertical angles that are created by two lines that intersect, and then here is a second pair of vertical angles that are created when two lines intersect. So this statement is true, this statement is true, but this is not the answer. When two parallel lines are cut by a transversal, so here we have two parallel lines, let's go ahead and label those as parallel by drawing these arrowheads here. Just a quick reminder that tick marks means that the lines are congruent, and that's always true. Lines are always lines are always congruent, but we want parallel lines, and two parallel lines are cut by a transversal, so this black line here is your transversal. Then any two angles formed are either supplementary or congruent, and that is true. So these two angles here are alternate exterior angles, and as long as these two lines are parallel, they will be congruent. And you'll remember also that angles 3 and 4 would also be alternate exterior angles and would also be congruent. And what should I do here? No, I don't have easily available, so I'll back out of that one. Yeah, let's just do that. Let me do that real quick, because it's good to put this in our mind. Oops, there we go. So can you guys pull out your 1.3b? Is that the one? No, 3.1. There it is. 3.1, if you would please. Pull out your 3.1 notes, and let's just quickly review those relationships here. That'll be helpful for us. Don't want to take too much time, but nor do I want to go too fast through this. I think that'll work. Okay. So quick reminder, we were just talking about alternate exterior angles. Those are congruent as long as the two lines are parallel. And here's another pair of alternate exterior angles that are also congruent. And then alternate interior angles. So alternate interior angles are also congruent as long as these two lines are parallel. And then here's another pair of alternate interior angles. And then what about angles 2 and 6? What's the relationship between those? And those are consecutive. No. Got it wrong, didn't I? Those are corresponding angles. They're in the same relative position, and those will be congruent as long as these two lines are parallel. Angles 1 and 5 are another pair of corresponding angles, and then angles 3 and 7 are also corresponding, and then angles 4 and 8 are corresponding. So all of those pairs of angles are congruent to each other as long as those two lines are parallel. And then same side interior, so angles 4 and 6 are same side interior, and also angles 3 and 5 are same side interior. So what's up with same side interior? We'll look over in the back side of those 3.1. Look at your 3.2. So like we just said, corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are also congruent. But what's up with these same side interior angles or consecutive interior angles? They're supplementary. So for example, angles 4 and 6 here, the sum of these two angles will be 180 degrees, and also angles 3 and 5, the sum of those two angles will be 180 degrees. So going back over here, this statement is also true. That statement is also true. But they're asking for which one is not valid. So that one is not the answer. And this A is correct. So I should say it this way. A is the answer. So why is A the answer? And what's the best way to do that? Let's do this. Let's go back to your 1.4b, but it's your 1.4b and the construction. Well, we did just talk about, look at the instructions for construction, so we could do that. But let's also look at this workspace here. There it is. So remember this this 1.4b workspace? What we just talked about earlier in this video was this here, and bisecting a segment. We can think about that, but it's a little bit clearer to have it here, a little bit bigger. So going back to this question originally, it says any point that lies on the bisector of a segment is equidistant from the endpoints of the segment. So get that in your brain. Any point that lies on the bisector of a segment is equidistant from the endpoints of the segment. And at least for me, I feel like I'm rushing through this stuff. So you might want to pause the video and just kind of slow down and get that in your brain. But looking at this situation here, this construction, what they were saying was that any point on a bisector of a segment. So this blue segment is a bisector. It's going through the midpoint and it's bisecting this black segment. And they're saying that any point on this bisector of a segment is equidistant from the endpoints. So in other words, is the same distance from the endpoints. So is that true? Are these two segments, the pink segments here, are they congruent to each other? And obviously not. So it's not true that any bisector of a segment is equidistant from the endpoints, but it is true that any point on a perpendicular bisector, so that is an important principle for us to remember, any point on a perpendicular bisector is equidistant from the endpoints. But they did not include the word perpendicular here. So going back over here, if they would have said perpendicular, then this statement would be correct. But because they don't say perpendicular, this statement is false, and because this statement is false, it's not valid, and that's our answer. I think that's tricky. That's a lot of geometry that you have to know, and even the logic of it is tricky there to remember that it's not valid is what we're looking for. Okay, so for this one, if you create an equation. All right, so let's take a look at this. So the measure, remember what this is saying here? Because it's kind of tucked into the vertex, it's saying that the measure of this angle, so here's the angle that we're talking about. The measure of this angle is 10x plus 10. And then down here, they're saying that the measure of this angle is 10y minus 10. So what is the relationship between these two angles? And you'll remember there are vertical angles. They are across from each other, opposite from each other. And what is true about vertical angles? They're always congruent. So going back over here, hey, we could say 10x plus 10. And then, so remember that's this angle up here, do it that way. And then let's relate it to this angle down here, which is 10y minus 10. Right? So what can we say about these two angles? We're accustomed to doing this, right? We've done this before. But what would that be saying about these two angles? It'd be saying that they are supplementary. The sum of these two angles is 180 degrees. Well, is that true? Are these two angles supplementary? And the answer is no. We said these angles are vertical, and so therefore we want to put an equal sign between the two of these. So this is a true statement. This is a true equation. But will this help us to be able to solve for x, right? Our goal is to solve for x. I'm sorry. We want to solve for y. So will this help us to solve for y? Well, we do have y here. That's cool. I like that. But could we solve this equation and have it be y equals just a number? And the answer is no. And why not? Because we have this this x here. So because we have two different variables, we're not able to solve this equation for just one of those variables. So we should have picked up on that. We should have said, hey, this is an x here, here's a y. Yes, we want to solve for y, so we definitely want to use this expression down here, but we cannot use any of these other ones here, because this one also has an x and that one has an x. So what do? Well, we got to figure out what x is, and then that will allow us to be able to find y. So now what's the relationship then between these two expressions? Or let's first look at the angles. What is the relationship between these two angles? And as you know, they are adjacent to each other, and they also create a linear pair, right? This is a line that should use a different color, eh? There's a line that's created by these two angles, and so a linear pair, remember, they are always supplementary. So linear pair will always be supplementary. And what's the definition of supplementary? The sum of the angles is 180 degrees. So therefore, I do not, as you know, I do not set these equal to each other. These angles might be congruent, but we don't know that. But we do know that they are supplementary. So let's do the sum of these two angles is 180 degrees. And so now, now that you have this equation, please write this equation down on your paper, and then solve it for x, and then come back to the video. And once you do solve it for x, I think I have this set up. Yeah, there. You should have x equals 10. So once you solve this equation for x, you'll get x equals 10. Let me just do that real quickly for you. So always draw your line down through the middle here. And now you want to simplify both sides. This would be 16x, and then let's add these, combine these other like terms, plus 20 equals 180. And then you want to move the constant away, so subtract 20 from both sides. And of course this cancels out because it turns into 0, and that's 160. And then now push the coefficient away to the other side, so divide both sides by 16, and we get x equals 10. So I will allow you guys to use a calculator in this upcoming test. So x equals 10, got that, but what do we do now? Well, I still want to solve for y, but now that I know what the value of x is, I can substitute that in for the value or into x. So I know the measure of this angle here is 10x plus, 10x plus 10. Oops. 10x plus 10. And so I can substitute this 10 in for the x. So now I have 10, and then put a 10 there, plus 10. And what's the operation between the 10 and the x? It's multiplication. So 10 times 10, which is 100, and then plus 10 would give us 110. So the measure of this angle is 110 degrees. And now we want to find the measure, Is that right? Yeah. The measure of this other angle. So let me do it this way. And actually, that's pretty easy. Now that I know that the measure of this angle is 110 degrees, what I can do is just to figure, so I know that these two angles here are vertical angles, and they are congruent, and so therefore this angle here will also be 110 degrees. Yep, we can just do that by geometry. Yep, that's probably the easiest way to do it. I had another way to do it. What I was going to do, I'll just go ahead and tell you. I was going to do this 10x plus 10, and then relate that to 10y minus 10. And because they are vertical angles, set them equal to each other. And now I could plug in the 10, the value of 10 in for x, and then solve this equation for y. But it's so much easier to just plug in the value of 10 for x, and then solve for the measure of that angle, the blue one, and then we know it's going to be the same measure for this other angle here because it's vertical. So either way will work for us. Yes, that's what they did here. Whoa, what happened? Oh, that's so. I'm so glad that I did that. I'm tired. It's like 3 in the morning now, so that shouldn't be an excuse though. But so it is true. So what I said, isn't that funny? What I said that this angle down here is 110 degrees. That is true, but that's not what they're asking for. They're asking for the value of y. So I could say 10y minus 10 equals 110, and then solve for y. That would work. Let me just go show you how that would work. So you would add 10 to both sides, right? Here, and this cancels out. So now you have 10y equals 120, and then now you want to push the coefficient over to the right side. So you divide both sides by 10. Now you get 12. Okay, so that's like 2 different steps you could do it, or the way that I was talking about that I could have done is the way that this student did it, was that they just created, is that what they did here? No, that's smart too. What they did was they said the measure of this angle, I like that. So there's different ways of doing it. The measure of this angle is 70 degrees. Right? We had, I guess he or she plugged in the value of x into here, and that's smart. 6x, that's not exactly right there. So I don't know where they get 60 from there. Oh, I see. So 60 is, yeah, they plugged in x, the value of 10, 10 for the value of x into here. So 6 times 10 would give you 60. There it is. And then plus 10. But why did they add another 10? I think they got confused there. So 60 plus 10 gives you 70. So the measure of this angle is 70. And then they said, okay, so these two angles here are adjacent and linear pair, supplementary. So this 70-degree angle plus this pink is going to equal 180. So that's where they got their equation, and then solved for y. Okay, so a few different ways of doing that. Let's move on. So please do take time on your own to think this through. And on your paper, of course, so this is USA 2 review number 2. Review number 2. So these aren't too, it's not as bad, let me see it that way, doing these problems on paper. So if you do it on paper, then identifying what these angles are, so MKN, this guy over here. So what I might do is like put numbers on this, like this is 1, and then I would put a number 1 down here to help you to connect these letters with the the diagram. Okay, so if you were taking this on the computer, can't quite see everything there. Let me just back it up a little bit. Okay. So if you were taking this on the computer, right, all you're going to see is this on the screen. So what are you going to put on your paper? And I recommend that you just do something like this on your paper and then label these angles with numbers. And then you would say, okay, 1 and 2, is it 1 and 2? MK, yeah, MKQ, this is 2. So 1 and 2 form a linear pair. And okay, that's the definition of linear pair. That makes sense, and so forth. Because it's hard to do it on the computer. You will not have colors like this. So it's so much easier when you have colors. Okay, so blue and green. Oh yeah, that's a linear pair. They are adjacent and create a line, so it's a linear pair. And also the red and green. Yep, going this way. The red and the green. They also form a linear pair. That makes sense. So what are we doing though, going from this statement, the first statement, down to the second? Well, the only thing they change, as you can see by the colors, the only thing they change is instead of linear pair, they're saying supplementary. How can they do that? Well, that's a postulate, right? That's an axiom. It's just obvious that if they create a line, then the sum of these two angles is going to be 180 degrees, and that's what it means to be supplementary. And so how do we go from steps 2 down to step 3? Well, all they're doing is saying that these angles, first we said that the angles are supplementary. Now we're saying the measure of those angles, the sum of the measure of those angles is 180 degrees. And that's the definition of supplementary. But then what are they doing here? To go from step 3 down to 4, well, here we have blue plus green. There's blue plus green. And we know it equals 180. But now they're saying that it equals this, what color is that? Pink? Pink plus green. So here we had the pink plus green. There's pink plus green. So first we started out with that this kind of messing myself up here. So let's do it this way. No, I guess we can do it that way. That's okay. So the blue plus green is equal to 180, and 180 is equal to the pink plus green. So what they're doing is substitution or transitive. All right. So remember how transitive said if A equals B and B equals C, then we can say that A equals C. We're starting at A and we're traveling through B to get over at C. That's what we're doing here. We're traveling from here, going through the 180 and ending up over at the blue there. So, or you could think of it as instead of, let's see what we're doing here. Instead of saying 180 in this, go to black here. Starting with this, instead of entering 180, because we know that 180 is equal to this guy, let's substitute this one in for 180. That's what they have. So blue plus green, that's the blue plus green, equals, and instead of 180, as a substitute for a 180, we're putting in this pink plus green. Okay, so that's substitution. So it is helpful to kind of think that through and make sure you have a sense of what they're doing there. But now, what's going on here? What should we write in to this place here? Well, they're saying that they're using the subtraction property. So which one of these would represent the result if you were to subtract something from this statement? Well, what can you subtract? Remember, the subtraction property of equality says you need to subtract the same thing from both sides. And so what could you subtract from both sides of this and still be equal to each other? And the answer is the green. So if I was to take out the green, so I am subtracting the same thing from both sides, then I would end up with the blue and the pink there. So that's my answer. And yes, I got that right. I was wondering if I'm getting too tired here, but I got that right. Okay, so they're subtracting the green from both sides, you end up with that. All right, we just have a few more to go here. Here we go. So if you would pause the video, think about this. We want to find the measure of angle A. The measure of angle A that will make these two lines. This is line T and this is line K. We want to make these two lines parallel. So let's ask ourselves, let's go ahead and put in labels here. So let's label these. If these two lines were parallel, what would be the value of A? Is another way of saying the same thing. Okay. So as we look at this on the computer, what should we draw on our paper? So here, do I need to draw this line here? Does this blue line help to form any of these angles? Does it help to form angle A? No. Does it help to form this 2x minus 10? No. Does it help to form this 3x minus 20? The answer is no. So let's not include this line on what we draw on our sheet of paper. How about this line? Does this line help to form any of these angles? And nope, does not help to form that one, nor this one, nor that one. So let's not include that angle. And how about, or that line? How about this line? Does it help to form? The answer is no. Okay, so on your paper then, if you're doing this by computer, all you would draw is just these two parallel lines, those two parallel lines, and then this transversal. So this is what you would put on your paper. And 3x minus 20. Okay, so it's just as simple as that. So don't get confused by all these other lines here. That can really distract you. But it's going back to this simple scenario that we've seen before. So yeah, I want to solve for the measure of angle A. Right? I want the measure of this angle, but it'd be nice to know the measure of this angle here, because these two angles are vertical and they are congruent to each other. So that'd be nice, but I can't figure that out. I do have these two angles, at least an expression of those. And what is the relationship between those two angles? Those are alternate interior angles, and therefore, as long as these two lines are parallel, then those two angles would be congruent to each other. So I can set these two expressions equal to each other and then solve that. And what did I do on this PowerPoint? Do I have the answer here? And the answer, I don't. Okay, so let me go ahead and just show you real quickly. So I would say 2x minus 10 and 3x minus 20. So what's the relationship between those two angles? They are congruent to each other. So let's solve for x. Let's solve for x. Both expressions are simplified already. So now let's bring this variable to the other side. So bring all the variables to one side. So subtract 3x from both sides. And so this is going to be negative 1x minus 10. That cancels out, turns into an invisible 0. And so now I have negative 1. I don't like this negative 1x, but that's fine. Let's do negative 1 x minus 10, and that equals, what do we have over here? This was minus 20, right? Don't forget that minus sign there. And yep, there we go. So now let's push away the constant from the variable. So let's add 10 to both sides. Add 10 to both sides. That cancels out. Now I get negative 1x equals, and what is that? Got to be careful with this one. This is negative 10, right? These negatives, be careful with those. So now I want to move this coefficient of negative 1 over to the right side. So you can think of it as I'm dividing both sides by negative 1. Negative 1 divided by negative 1 is positive 1, and I get x equals 10. Okay, so now I had the value of x equals 10, and now I can plug it in to, I would probably plug it into this expression here. And so now I get 2x minus 10 and 2, and now instead of the x I'll plug in the 10 and then minus 10. And of course, what is the operation between the 2 and the x? It's multiplication. So now that's 20 minus 10, and so now the measure of this angle is 10 degrees. The measure of this green angle here is 10 degrees. So now what's the measure of our, let's do a different color here. So what's the measure of angle A? Well, they're adjacent and linear pair and supplementary. So therefore this one's going to be 170, or you know that I would subtract the 10 from 180. Right? The definition of supplementary is the sum of these two angles is going to be 180 degrees. And did we get the right answer? Whoo, we did. Got the right answer. All right. Okay, so we're using geometry and also algebra. So please read this thing through. And what did I give you guys? This is review 1. What question was this? Number 3, is it? No, number 6. Question number 6. And yeah, so this is multiple choice also. And that will be the way that it's on the test, right? So if you would take your time and read through those. So what is the contrapositive? Contrapositive. So let's go ahead and have you pull out your 2-point, ouch, my back is hurting. So let's pull out your 2.2, I think it is, or is it 2.5? Yes, 2.2. Yep, there it is. Okay, so quick reminder of 2.2. And remember, we said if hypothesis, then conclusion. If hypothesis, then conclusion. And we have these different things that we can do to a conditional statement. Remember, converse is to switch the hypothesis and the conclusion. Inverse is to negate the hypothesis and conclusion. And then contrapositive is to do both, to switch and also to negate those two. So when they say contrapositive, then, okay, so here's the if hypothesis, then conclusion. So we want to switch and negate. So let's find one that switches them. So this switches it. Let me do it this way. Let me do different colors and see if this will work. So if hypothesis, then conclusion. So we want this, the first one to start here, to be alternate interior angles are congruent. And actually we want it to say not, right? Because we want it to be contrapositive. So is this one going to work? And it has not there. I like that. And then here I want this to say is not a transversal. So that matches and is not parallel. Two parallel lines are cut by. If two parallel lines are cut by a transversal, then, yeah, that still works. So it's not a transversal. I could say that, but really it's saying not parallel. Not parallel. Yeah, so I think that's going to be your answer. Let me check that to see if I get it right. Yeah, it's not going to be that. Yeah, it is. Good. Phew. So these other ones, why are these other ones not correct? So primarily, let's do this. So if two lines cut by a transversal are not parallel, Yeah, so it's because they didn't switch it. They have the negation, but they didn't switch it. But this one, and notice here, they did negate one of them, but not the other one. So you do have to negate both of them, but it's also not switched. And here, so what's the difference between these two? Oh, here they negated one of them. Yeah, they negated one of them, but they didn't switch them. They should have switched that. Would have made that harder. So be careful. Even if they switch it, but they don't, or let me say it this way, they have to switch them and negate both of them. In order for it to be contrapositive or to be inverse, they have to negate both of them. They must negate both of them. So this is your review number 1 and question 8b. I want to find angle 3, right? The measure of angle 3. So how do I do that? Can I relate that to these angles up here? And the answers are no, because I do not know that these two lines are parallel. If those two lines were parallel, that'd be okay. I could relate those two. In fact, they would be corresponding. That'd be nice, because the measure of angle 3 would be 50 degrees. But we do not know that these two lines are parallel there. However, I do know that these two lines are parallel, because that's what they say up here, that those two lines are these roads here are parallel. So I can relate this 40 degree angle to one of these other angles here, and to try to get over to angle 3. So looking at angle 3 and angle 4, here's your transversal. They are on the same side of the transversal, but remember this is interior and this would be exterior. So oops, exterior. So angles 3 and the 40 degree angle would be same side exterior. We don't have such a relationship there. Hey, we do know, are familiar with the relationship between angle 2 and the 40 degree angle. Those are alternate exterior angles. And so we do know these two lines here are parallel. So therefore the measure of angle 2 is going to be 40 degrees. They are congruent. Alternate exterior angles are congruent to each other. So now what we can do is relate angle 2 and angle 3. They are adjacent and linear pair and supplementary. The sum of these two angles is equal to 180 degrees. So take 180 and then subtract from that angle 4, and we get 140 degrees. So the measure of angle 3 is 140 degrees. Yabba dabba doo. And of course you know that angles 3 and 1 are vertical angles. So if angle 3 is 140, then angle 1 will also be 140 degrees. Whew, we are done, and I am done. I'm ready to go to bed. So thank you for enduring and persevering and watching through this. I hope it was helpful, and I look forward to seeing you guys in class soon.